All right, so we're formatting our diagram to look like this. We have those three major parts again. We have your solid, liquid, and gas. Now, one of the things that what are the two, well, let me ask you this question. What are the two variables that are graphed here? What are the two variables? Look at your X and Y axis. Pressure and temperature is exactly right. And you're going to treat them just like you have treated every graph since 4th grade when you learned how to do ordered pairs. We're going to act like they are ordered pairs, okay? So if I give you a temperature of negative 15 degrees Celsius and I give you a pressure of 30 atmospheres, can you tell me what state of matter this substance is in? Solid. Very good. Just like X and Y. So that point would be right here in the orange section because your X would be negative 15, your Y would be 30, where they meet would be in the orange. So it would be a solid. What if I was here and I said, let's keep the temperature the same, keep the temperature the same, but I'm going to drop the pressure to 1 atmosphere. What phase of matter do I have now? A gas is exactly right. What if I have a pressure of about, let's say 200 atmospheres of pressure and 50 degrees Celsius? 200 atmospheres of pressure, 50 degrees Celsius. What state of matter do I have? Liquid is exactly right. Because 200 would be here, 50's here, where they plot their point, would it land up in that little, looks like a slice of pie, right up there, the green slice of pie for liquid, right? So you're going to treat these just like ordered pairs. Now, think about your phase changes. Do you see these lines of the Y, the lines that make the Y? Those lines are noting the phase change, okay? So we talked about plotting those points. If I were to plot a point that landed like on this line here, or on this line here, or on this line here, it would mean it's in between those two phases. It would be both solid and liquid, or it would be both liquid and gas, or it would be both solid and gas. So those lines note a phase change. It's going to be the same phase change as we already know. So tell me, if I go from a solid to a liquid, what that phase change is. Melting. Good. So I'm going to draw an arrow and I'm going to label it melting, going in that direction. Now, vice versa. If I go from a liquid to a solid, what do I do? What am I doing? What phase change? Freezing. That's right. So I have those two phases. So again, that line is going to note where your freezing point is and where your melting point is for this substance. I don't know what this substance is. This substance could be water, it could be hydrochloric acid, it could be oxygen, it could be gold. I don't know what it is. It doesn't tell me what it is. It's not titled. Only thing I know is that at certain atmospheres and at certain temperatures, I can tell you what state of matter it's going to be in. And by changing one or the other, you can change the state of matter it's going to be in. Now, let's look at this phase change right here between a liquid and a gas. No, a liquid and a gas. Not sublimation. Liquid to a gas is vaporization. Okay? Now, some of you said evaporation. That is a form of vaporization. So is boiling. So anything on this line could be your vaporization point or your boiling point. Now, if I go backwards, gas back to a liquid, what's that change called? Condensation. That's right. All right, let's look at this bottom. Underneath this point down here, going from a solid to a gas, what's that phase change? Solid directly to a gas. You know it.
Sublimation.
Sublimation. See? I knew you knew it. I hope you know it anyway. All right, and then what's the opposite of that? Gas going back to a solid. Close, yeah. Deposition, right. Which comes from the word depositing, right? So that is a deposition. There we go. So those are our phase changes. And remember, if we have a point that lands on those lines, then that substance can be in both phases at once. So if I land somewhere on this line, you're going to have something like a slushy-like texture, right? If it's low temperature and pressure, because it's going to be, some of it's going to be solids and some of it's going to be liquids. So you got, your slushy line, your melting freezing line. Now there's two good points that we need to look at, and I made them real big, I exaggerated them. This point right here is a point called the triple point. And the triple point is just what it seems like. It's very, very common sense. You have three phases of matter. What do you think might happen at the triple point? They're all going to be present. Is exactly right. All three phases of matter can exist at this temperature, 0 degrees Celsius, and at this atmospheric pressure, 30 atmospheres. So if you find yourself, whatever the substance is if it finds itself in a state of 0 degrees Celsius and 30 atmospheres of pressure, it can possibly be a solid, a liquid, or a gas, or a mixture of all three. That's the triple point. Three phases, triple point. Makes sense, right? Triple three, right? You get 3 points for a three-pointer, triple shot, right? So here we go. This last one up here is your critical point. Now, we're not going to deal a whole lot with critical point, because after you get past this point, you're dealing with something called a supercritical fluid. I'm going to leave this for your number one, because we just don't have time, and it's a lot of physics. So physics and higher level chemistry, they might talk about things that are supercritical fluids, and that means that it's behind the liquid and gas. It means it's indistinguishable. You can't tell the difference between a liquid and a gas, and it's right there at the point at this temperature and pressure. So when this gets up to around, I don't know, maybe around 200 degrees Celsius, and it gets to about maybe 290 atmospheres of pressure, then this becomes indistinguishable between a liquid and a gas. And it does some kind of funky stuff. All right? So now we're going to make ourselves some notes. I'm going to switch over to this note side right beside it. And we're going to make ourselves some notes. And these are just, again, notes to self of how to read a phase diagram. So we have to remember the important things that we just said. So the very first thing that we just said is we are going to treat the temperature and pressure like things you already know how to deal with. What are the two things I said to treat temperature and pressure like? Since 4th grade, you've been using them.
Graph.
Like a graph, like an X and Y coordinate is exactly right. You're going to act like this is a coordinate grid. Your temperature is on your X-axis, so it's going to be your X coordinate. Your pressure's on your Y-axis, so it's going to be your Y coordinate. It looks super difficult. I always like learning things that look really difficult, and then realizing they're not really all that difficult, and then figuring out, and then you feel really smart. So I think that's kind of cool to learn new stuff that looks really difficult. Now the next thing that we need to put in here is something about standard temperature and pressure. Sometimes standard temperature and pressure, sometimes called STP. You have a standard, so they might ask you a question on a practice page or something that says, what state of matter or what phase of matter is this substance in at standard temperature and pressure? Well, you got to know what standard temperature and pressure are. Standard temperature is 0 degrees Celsius, and pressure is 1 atmosphere. Not too hard, standard. Remember, we're at 1 atmosphere pressure. We're not at 0 degrees Celsius because that's where water freezes, but we're at room temperature. But these are standard temperature and pressure, 0 degrees Celsius and 1 atmosphere pressure. So over here, if I were to ask you on our graph, look at 0 and 1. What is this phase of matter, of this substance, at standard temperature and pressure? Look over here at the graph. 0 degrees Celsius, 1 atmosphere of pressure. It's in a gas phase. That's it. It's in a gas phase at standard temperature and pressure. It's exactly right. All right. The very last things that we're going to put on here, just to remind ourselves what the triple point is. Tell me in your own words what the triple point is.
We're all phases of matter.
Right? All three phases at once. All three phases can exist at the same temperature and pressure. I just put all three phases at once. That tells me to remember what that is. I don't have to put it a formal definition. And quickly, what did we say about the critical point? Liquid and gas. You can't tell them apart. Now, you could use that big fat word, indistinguishable, and that would be fine too. So that is how we read that. Now, I've thrown a lot of like how-tos and what-ifs at you and some instruction, but if we don't practice that instruction, you're going to lose it. So we're going to take a few minutes. If you turn on the back, and there's some practice questions and a practice graph. Okay? So we're going to go through these together. But before you start, I need to make a couple corrections to the graph itself.